Welcome everybody to our first youth run program. I'm calling him a youth. I think this is our youngest yet presenter for a colloquy. At least I can be very proud. This is my mama moment. So this is my son, Maxwell, who will be presenting this evening. This is our first ever Village Voices because we're moving. We've been the community colloquies now for 3 years, and the entire community is still wondering what the heck that means. So we're going to try for Village Voices for our new alliteration. So welcome, and I hope this is a great evening for you. I hope you learned something. I hope you feel comfortable asking questions. I would say, just because Max has a lot to cover, try to ask clarifying questions during the presentation. And then at the end, if you've got deeper questions, he'll be ready for you. He's got so many slides ready for any question you throw at him. The restrooms are down the hall to the right. There's 2 ungendered restrooms. There are people also joining us online, so we're recording this. Please silence your phone. And I want to thank Max for putting in, I don't know how many hours. He's really enjoyed this. You'll find out exactly how much he loves computers in just a moment. So thank you for being here, Max.
I'll hear the music earlier. Let's see if we can bring back. This is all AI generated video and audio. Just a little sample. All right. Yes, so that's me and my wife, Erin. Maxwell Mullin. I live in Troy, Ohio right now. Hoping to make that Yellow Springs in the near future. Getting there. I graduated from Ohio University with a degree in computer science. And I currently work as a data engineer at 8451, which is really just part of Kroger. I want to just clarify, my presentation today is my own opinion, doesn't have anything to do with 8451 or Kroger. Just want to give that disclaimer. So I've always been into computers from a very early age. This is me in high school, Yellow Springs High School. I started the computer club, which I think doesn't exist anymore. But we learned about computers, built computers, took them apart, and even built a computer in Minecraft at the time as a collaborative effort. So yeah, learning and teaching about computers has always been a passion of mine. So I currently work at 8451. That's a marketing insights company, which probably doesn't mean a lot to you. It doesn't to me. Basically, we optimize everything about the Kroger experience, the online shopping, the coupons you get in the mail, where things are in the store, all that. It's all trying to figure out how to make the store best work for, well, the store and for the customers. Well, I'm pretty into computers, so, and you know, for fun, I have a server at home I get to play with. So I'm pretty passionate about AI. I really enjoy this stuff. I think you should be too. So I'm hoping to excite you about AI and start you on the path to leverage it for yourself. There's so much to talk about here that we're going to have to move at a frankly disrespectful pace. we're gonna skim over some stuff, and that's fine. I just want you to know this is a starting point, and there's like much more. If this interests you, there's much more to dive into. So to make sure we're all talking about the same things, I want to define a couple terms, just to make it a level playing field. So let's define a program or an algorithm. All that is a rigid set of instructions the computer follows to perform a task, right? That's distinct from AI, which is a program that learns from data how to perform a task. What that means is the original programmer doesn't necessarily understand the problem they're solving. Like, for example, the programmers that made Deep Blue that first beat Kasparov in chess, they weren't necessarily grand masters of chess. Like they weren't amazing at chess. They were good at programming, and it learned from data, right? It became better than its programmers at that task. Another term you'll hear a lot these days is large language model. That just is a special kind of AI that's trained specifically on text data. The difference is not super important. So I want to talk to you about why you should care about AI, why it matters to everyone, in my opinion. There's this device, ancient device, a Palm Pilot, maybe you've heard of it. Maybe some, I've used one even. It came out with a interesting design choice. It had something called graffiti. And maybe some of you know this, it's a special way of recognizing handwriting so the Palm Pilot could take your written instructions or you keep your to-do list in it. This is actually a compromise in design. Because at the time, machine learning and artificial intelligence was not very good. We had not developed these techniques yet. And since the 60s, from the 1960s till 1994, when graffiti was first released, people worked tirelessly to try and write programs to recognize where one character started and stopped and what is the character and like maybe this is a digit or maybe this is a smudge of ink. We don't know, right? It's a very challenging problem, surprisingly challenging problem. So this is Palm Pilot's compromise because they couldn't solve the problem after decades of research, industry-wide, not just at Palm. So nowadays, your phone can recognize your handwriting, no problem, right? And that's not because some genius programmer figured out how to figure out where the characters start and stop. It's not because some programmer figured out, you know, a special algorithm to follow. It's because they use artificial intelligence. They let the machine learn for them to become better at a task than they were themselves. And now handwriting is a task that in 2016 we did in my class as an extra because we had extra time during class. It's so accessible now that it's not nearly as big of a deal. A more modern example of why AI is really important. Say you're a researcher, or even better yet, how about a lawyer? If you're a lawyer, sometimes you go through discovery, right? You get dumped of hundreds of thousands of documents, just crazy amounts of text. Well, I could go through and read all of that, but wouldn't it be better if I could just have an artificial intelligence tell me what papers are actually going to be relevant to my case? You know, I don't, you know, like the Enron emails are now public and you can go through them and there's just troves of random garbage. No one cares about half of it. But with AI, you can say, hey, go find things related to, you know, whatever legal case I've got. It really decouples the lawyer's ability to think from his physical limitations. I think that's the key thing is artificial intelligence decouples our ability to think from our physical limitations. There's a lot of other things that have come about that do the same thing for humans, just decoupling our ability from our physical limitations. The internet is a great example of this. It decoupled the information distribution, which let us have global communication. So for context, like Wikipedia is a valuable resource, but if we were using libraries to keep a physical copy of Wikipedia updated, you need 6 printers printing round the clock at every library. And you imagine those librarians, they have to file each page. Oh, this one, you know, this squirrel's got an update, got to put it in that stack. And oh, there's another update over here. So it would be chaos, you know, but the internet has enabled something that we could not do. We could not manage physically beforehand. Computers in general have decoupled our ability to calculate and let us solve new problems. In fact, the reaction time of a computer is insane. The reaction time of your brain to light hitting your eyes is 250 milliseconds, which seems pretty fast, right? It's not bad. A trading computer on Wall Street will regularly hit 800 nanoseconds. That's 300,000 times faster than your eyes react to light. It's really fast. Horsepower and steam engines. I think that's pretty clearly beyond what we can physically do. Another technology has decoupled our ability from physical limitations. The printing press decoupled our ability to remember and to share information, keep records from their ability to push a pen, or reading and writing, or decoupled those same things from our ability to remember and retell accurately, or even to listen. So I think artificial intelligence, that the pinnacle of what artificial intelligence can achieve is very high. I think that's why it's really important to understand. Now, there are a couple different levels, we'll say, of artificial intelligence, which I'd like to just quickly define. We'll use humans as a benchmark because they're the most intelligent thing we know right now. And we'll talk about some examples and when they first became available. So narrow AI is probably what we're most familiar with now. That's going to be things like chess bots. It's not strange for your phone to be better at chess than you these days. But there's specific and well-defined tasks that are really good. And what I mean by that is if you took the chess bot and you said, can you drive me to the mall? It would not go well, right? It wouldn't get you there. And that really kind of first became available in 1997. Sort of the more generic, if you will, AI is good at multiple tasks within a domain. So what I mean by that is like an autonomous car, it's able to handle, it's going to be better than humans at staying within a lane. It doesn't get tired, it doesn't go out drinking, it doesn't have medical issues. Like it's going to be better than humans in that. It might not be better than humans at understanding a traffic cop signaling for you to, make a left here, right? So it's better than humans in a lot of tasks within a domain, but it's not better overall. Not yet. ChatGPT, we'll talk about some later, is also better than humans at some tasks. AGI is artificial general intelligence. The general meaning it's good at pretty much anything a human's good at. I will say AGI in particular is a definition it's a moving target. Depends on who you ask what the definition is exactly. I think an interesting one is when artificial intelligence is better than humans at most economically valuable work, which feels like a pretty important tipping point. And we certainly don't have this yet, but depending on who you ask, they'll tell you next year, 2 years, 50 years. We really don't know. We have no idea.
Give an example of what you.
Of AGI?
No, of economic value.
I mean jobs. I mean jobs. All any talking programmers, writers, car drivers, anything is what we're talking about potentially. And I'll stress again, we really don't know. Like this is something we're a lot of experts. Like if you take a room of scientists, computer scientists, and poll them, they'll say on average 25 years out, roughly. If you ask CEOs of important AI companies, like Sam Altman is the CEO of OpenAI, and he says later this year. Who knows? He knows more than we do. He has more information than we do, but also he has an incentive to be soon. But the CEO of Anthropic, which is a similar company, says 2026. So it could be soon. We don't know. The final category is ASI, which is artificial superintelligence. And this is kind of where we get into like thought experiment level, like way out there. This is where a lot of people have sort of doomsday scenarios they worry about. And this is where we're talking about like smarter than all humans combined is a pretty common metric. And that obviously we don't know what AGI is. Just, I didn't put a number down, no way. This is we're in the realm of theoretical and an interesting thought experiment, but maybe not super relevant to today. So, any questions over that before I keep going? I don't want to lose anyone. Yeah.
Seems like it wouldn't be that difficult to fool it.
Yeah, you would think, so
There's a lot of interesting things with intelligence. We're used to computers which are not intelligent. You know, they have intelligent programmers, but they're not intelligent. And we have a lot of experience with, you know, the computer can't figure out what's going on, and you're like, well, I just turned off the Wi-Fi. Like that's what the problem. You know, like we're used to these very simple problems, and we could talk more about the thought experiments around ASI. But
once it gets to a point that it is truly smarter than us, which theoretically is possible, we don't know. Not with today's technology for sure, but it could be possible in the future.
once you have something that's truly smarter than you, it's very hard to control.
And that's kind of why there's a lot of discussion around it. Yeah, Dave.
So two things, one relating to that is, so is the Turing test fitting into the ASI one, and you talked about economically valuable work. Do you see AI doing, electrical rewiring of an old building also?
Yeah, actually, I think
Not counting making machines that wander around, and making androids that, wander around.
yeah, I mean, so totally.
There's a whole realm of
Artificial intelligence that we're just stepping into, which is embodied AI. That's
artificial intelligence that has a physical form, a robot.
effectively. Or in some cases, there's some companies that make little clips that sorry, I'm touching the mic, little clips that you can talk to, right? Or, smartwatch, like it's kind of embodied, not really. But I do see like potentially some blue collar jobs could go to a sufficiently powerful enough AI. I mean, think about how many automotive jobs have gone to assembling robots and whatnot, and welding robots. Yeah.
Yeah, programmers for one and editors for another one.
Yeah, I think anyone that has a job sitting in front of a computer has a risk, right?
And I actually, where I work,
I use AI constantly.
that's a huge enabler for my job.
In fact, it's
Not required, but it's firmly encouraged to use artificial intelligence to help me write programs. Because as it turns out, about 80% of a program is
pretty similar to another program there, right? It's a set of instructions. So someone else has probably written similar code.
and it's much more useful for an AI to go ahead and
Pad out what you're writing. And I have to go in and curate what it does, right? I'm editing as we go, but
I'm not
so I'm not replaced by it yet. But we'll see. Yeah, one more and then we probably better move on. Go ahead.
So the AI that you use, how many people has it displaced?
That's a really good question.
So the question was, how many people have been displaced by the AI I use, which
Which
is
is Copilot mostly from Microsoft. I think that's an impossible question to answer, honestly.
Like you would suggest that there would be more than one.
So there's this interesting problem. I forget what the principle in economics is, but when you reduce the cost of something, you almost inevitably end up using more of it. There's some paradox. I forget what it's called.
so my theory personally is that my cost per
Useful program has gone down, right? I can produce more software per time, per cost effectively, because I have this AI agent. And that certainly on the surface is like, okay, then you need less employees, right? Well, turns out everyone's got an app idea,
everyone's got a piece of software they want. There's more software that we'd like to have than we can possibly program right now. So I think the answer right now is
There's certainly individual jobs that have been lost, but I think overall the number of jobs probably been about equal. We don't really know. It's there's not a lot of people labeling, oh, this job is only because there's AI or only because there isn't.
we don't know. Yeah. Well,
When I started programming Century, I made a statement, which I still think is true. If you took everybody in the world and had them write programs, that you wouldn't get them all done.
Yeah, totally.
yeah. For the people online, you said if you had everyone program,
You got everyone in the world program. You never get all the programs done, right? Yeah, totally. Totally agree with that. There's an amazing number of things that I would love to program. Long list of side projects I'd love to do. And, you know, if the cost was low enough, I would be able to do that, but I can't, you know, so. Yeah, it's almost impossible to know how many jobs have already been affected by this in aggregate, but you can certainly point to individuals that have been impacted already. All right, so let's talk a little bit about how AI learns. We're gonna get a very high level, like just what's the process. I'm not gonna get into the math too much because even I would gloss over on that. And we can answer more questions as we go, but. So this is the basic workflow when you're training an AI. I'm going to start at the bottom, maybe confusingly. Imagine I write a program that just generates a random formula, right? And I should say, let's say my task is I want to try and write an AI that's going to estimate the value of a home, right? I think we've all done this. If you've purchased a home or even rented, you've thought about what's the value of this place? Is this reasonable, right? So it's a pretty accessible task, I hope. So I could write a program that makes a random formula, and then I could go and get a lot of house sales, right? I could go on the MLS records and see records of what houses sold for, how many bedrooms they had, how many square feet they are, stuff like that. And I could evaluate that function, that formula, very easily against that test data set, is what I've just collected, those MLS records. And I could say, okay, I have 100 households that have sold, and my formula is terrible at estimating. They did a terrible job. I didn't get any of them right, not even close. Yeah. But maybe if I do a bunch of random formulas and I evaluate all of them, one of them did marginally better, right? And I can take that marginally better formula and put it back into the random formula mutator. I can change it just a little bit. You know, okay, square footage is a little bit more important, and number of bedrooms is a little bit less important. And turns out the value is really different. We have 0 bathrooms, you know. And I can keep doing this loop. I keep taking the best, changing a little, testing it. Keeping the best, changing a little, test it. And if I do that enough, I will get a formula that is amazingly good at estimating the value of a house. If I do it right? There's glossing over some details here.
Isn't it like using Amazon to shop and filter out this price range and this many widgets and things like that?
Yeah, so the question is like, is this like filtering down your search on Amazon? It's not dissimilar. In this case, it's like if you were shopping for a model, a formula model, same sort of thing. You'd be testing the different categories, if you would, or testing different search terms, trying to find what's the best way to structure it, and you're picking the best, right? And the advantage here is this is almost like if you're on Amazon, you click on a product and it says like, hey, here's some other products like this one. You imagine if you just you go on a random Amazon page and you click on the thing that's just slightly closer. You know, maybe I need a dog collar and I start on a sofa, right? Maybe one of the related products is a dog bed. So I click on that and then it says a water bowl. Okay, that's a little bit closer. And then finally, there's another related product on the water bowl for dog collars. So that's kind of what we're talking. We're making leaps towards a slightly better option over and over. So when you see this stuff on people talking about it, a lot of times they will show you some scary math. So all this is linear algebra. It's matrix multiplication. And basically we're saying in this case, like, hey, if I take my size times some weight plus my location times another weight, and you know, I do all this crazy math, this crazy formula, out comes my price. Right? And another way that's represented here is a neural network. This is the term we're talking about here. In this case, we have 3 inputs on our left, and then the weight is the thickness of those lines. And what we're multiplying those by. We add them up into
another value. This would be what we call a hidden layer. So here's another value. Maybe it has another weight we multiply it by. You see it's like we're doing all this like crazy multiplication and adding and munging of the numbers to get this value. And we don't really know how it works, right? If this is large enough, we actually don't really know what each bit of the formula is doing because we've trained it in this way where we're just
checking, did it do well? Yes or no? And if yes, then okay, try and change a little bit. We didn't really tell it how to structure this. So we don't really know. So yeah, you had a question?
I do, yeah, I do. So you're saying you're programming this algorithm to come up with a good best price. So, and you go through a series of iterations where you upgrade the algorithm, you test it to see if it has what you want it to do.
Right.
And if it doesn't, you do it again. Right. And so as a good programmer, which I'm sure you are,
sometimes.
every time you make a change to that program, you document the change that you made to that program so that you can follow the logic into why you did what you did, correct?
Well, you would hope so.
No, the answer is you should, right?
Well,
Yeah.
ideally you should. The really interesting thing is, part of why I bring up the neural network
Is this you could write a version of this that doesn't use or how do I put this? You could this particular setup of using a large matrix multiplication turns out to be extremely generalizable between lots of different kinds of tests. And the reason we use it
is because it's very efficient to do that. What we call training is the process we're talking about. It's very efficient to do that because of the matrix multiplication. There's a special bit of calculus that we're just not gonna, don't worry about it. There's a bit of calculus that lets us do back propagation, is what it's called. And basically we can adjust these weights so we don't actually have to throw away the program or necessarily mutate it. We can say, on this specific test question, this specific house, your number was too low. So back propagation lets us say, okay, next time guess higher. You know, we're not just making a random change, we can intentionally change the model. And the thing is, the way back propagation works, it's really hard to know exactly why we're changing each thing. It's really hard to document it. There are a lot of people working on how to do that, but it is like an active area of research of how to actually understand what a model is doing. Yeah, you had a question.
On a learning model on the first formula, the random formula.
Yeah.
Is that created by the computer or is it created by a person starts everything?
So it's actually probably easier for me to start here. If you imagine the model is these weights, these numbers, these are all just like some number between 0 and 1, right? Some
very precise decimal number. And typically what we do
is we just put random numbers in here, right? We don't really care because as long as we start somewhere, it will end up where we want to be. So the answer to your question is no one is really telling it exactly what to be. There's some stuff I'm glossing over here where like this structure is not quite as simple as what we're showing here, and we'll look at that in a moment. There's more complicated structure that we're not gonna bother with because
it's too much. We'd be here. There's a wonderful video I actually really highly recommend anyone who's interested in like the technical details of how this works. It's by Andre Karpathy, and there's a link to this later that you guys will see, so you can find it easily. Ironically, Andre Karpathy is one of the people who have done the most for self-driving cars. Karpathy, I find that hilarious. He has a 3.5-hour video going through the like true structure of large language models on this, and he's scratching the surface. You know, it's very complicated. We're getting to the basics here, but in principle, if you scale this up, and I mean really scale it up, this is what's happening under the hood. The same basic process. Today's state-of-the-art models have approximately 1 trillion of these numbers, right? With really large matrix multiplication problems. Okay, so I mentioned large language models.
That large language models are a special application of a neural net, where instead of taking a house's size and its location, or maybe the quality of the house, or the number of floors, whatever, instead of taking numbers, what if instead I put in smile for the, and then I wanted the model to predict the camera? Right? There's no reason it couldn't do that, right? I'm giving it data and like reasonably it could do that. If I had enough text to test it against, right? Just like the MLS records, if I had enough text to feed in as the starting phrase, I could get it to predict the next word. And that's pretty much what your phones do already for autocorrect, right? They're doing a little bit more because they're also like, well, maybe that last word was misspelled. Maybe I better tell them to fix that. So that all makes sense, except this is matrix multiplication. You can't multiply smile times 3. It doesn't make sense. So what we do is called tokenization. So I'm going to try and demo this. This is a little bit of a weird setup here, but so this is a website called Tick Tokenizer. And what it does is
TikTok?
it happens to have a similar name. So what we're going to do is we're going to tokenize a string. What I mean is we're going to take a series of words like oh, that's tiny. Can we make that bigger? You guys can't read that. It's too small, right? Shoot. Let's see if I can zoom this in at all. No, it stays the same size. Okay, well, I'm going to do my best to describe this. Maybe you can see a little bit of it, but I don't know how to make this bigger. Sorry. So basically, what this is doing is if I put in some words. So in this case, I've typed in sign for the camera instead of smile or whatever. And maybe you can see there's a couple different colored blocks up here. And what it's done is it's broken up the words into what we call tokens. And you can kind of think of tokens as just words, but it's a little bit more nuanced than that. We're actually breaking them up into the most common byte sequences, most common characters. So like the word the is its own token, but you know, if I put in probably like Mullin, it's not a common thing. So yeah, when I put in the word Mullin or my last name, it's going to break it into 2 tokens, Mull and in. And it's just trying to make them roughly as equally likely. It doesn't really matter. The point is, we're turning these into tokens and then giving them a number, just effectively a random number that we're going to associate that word with. And what we do is, for these large language models, these like ChatGPT and stuff, which we'll look at in a moment, we are taking the entire internet. I mean, every bit of text data you can find on the internet that's useful to anyone. And we're converting those words into numbers, and then we can train our model on that data set, and we can have it start to predict the next word for whatever we want. So turns out that's pretty useful. You know, if you have a program that's not quite complete, the next couple words are like what you need in your program, and that's very useful to a programmer, right? And we found a lot of really interesting ways to take advantage of models like this. And yeah, so for context, like we're still talking about neural nets, but these are screen here. Sorry. So for context, these are the neural networks we're talking about now. They're much more complicated. You don't really need to know what they're doing, but I want to give you a little bit of a sense of the complexity and scale we're talking about, and why we really don't know how these machines work. Right? They're too complicated for any human to really interpret. This is Nano GPT, which does very little. It's not very smart. It has 85,000 of these weights, and it's still not very good. I highly recommend looking at this website, which again there's an easy way to find the link later, and we'll put it in the description of the video for this recording. But this website does an excellent job of letting you walk through how the structure works. And let's see if I can here. So like it's even like animated. You can like go through and see all these different structures. So you can see these are all, each one of these dots is a little weight.
and it'll talk through like, well, now we're gonna do this step and here's how the math works. And so it's a wonderful website. But what's really nice is we can see they have the model for GPT-3. Now, you can't really see much of this, it's pretty large, but that little speck up there is Nano GPT we just saw with the 85,000 parameters. Now this is GPT-3, it's so big it doesn't even really fit on the screen, it's massive. And this is, GPT-3 is not even close to state of the art. It's like still a toy in the examples we're talking about.
Max, did GPT-1 create GPT-3?
Ah, that's a good question. So the question was, did GPT-1 create GPT-3? No. They're different structures, so they're going to be certainly inspired by, but we're talking about software engineers have decided what this structure should be and how the different things should interweave. There is definitely, we're not talking about just the computer deciding this architecture, this crazy tables put together in weird ways. So each GPT, which I should say, GPT is generative pre-trained transformer, which basically just means large language model. Certainly informed, but not directly. All right, so let's see if we. I have to like click out of the thing and okay, so let's contextualize this a little bit more on the scale because I really want to drive home that like these things are just, this is like bonkers how big these things get. So this is an NVIDIA H100 GPU. It retails for $30,000. Okay, it's a graphics card. It's basically what people use to play video games, but really, really powerful, right? It goes into a compute node with 8 or 7 of its friends to make 8 in a compute node. And that compute node goes into a rack. That rack has 256 of these $30,000 GPUs in it, right? So then you put that in a room with others. So now you have 3,584 GPUs in one room.
Why stop there?
Why not? So, okay, here's the largest supercluster, the largest supercomputer we've had on Earth up until recently, up until about 4 months ago. And they did this. And 3 or 4 days ago, they announced they're taking this supercluster, which has 200,000 GPUs in it, and they're 5xing it.
And how do they keep those cool?
They cool them with a lot of industrial coolers. In fact, I don't remember the exact number.
Use a lot of.
XAI is the owner of the current largest
Where
super.
does the heat go?
Yeah, the heat does go out.
The atmosphere?
Yeah, of course. Yeah, they have to vent to the atmosphere, just like any other data center. So I think they said, you can get like big trailers meant for refrigerating things. I don't know why they make them. Maybe for emergencies for grocery stores. Actually, it makes a lot of sense when the cooling goes out. They said they bought up in order to make this data center at amazing speed. Data centers normally take multiple years to build, and they did it in less than half a year.
What was they?
We're talking about XAI,
Which is Elon Musk's AI company.
yeah.
So they bought up a significant portion of the country's supply of these refrigeration trucks. I don't remember what the portion is, like a fifth or something like that. An absurd number. And when they 5x this, that's their plan
In the near future, probably within the year.
Their power consumption will be 1.2 gigawatts, which for the nerds in the room, that's exactly the same as the DeLorean from Back to the Future.
Right. What?
So they're huge. And in fact, they're so large that they have problems getting power into them, right? And no one makes multi-gigawatt hookups to the utilities. Meta, Facebook, also has
Data centers like these they do training in. And they actually have a flag that leaked, that they accidentally published this to the public. I can't find the exact listing, but I've heard this anecdotally that they have a parameter they can set in their program that's called power plant no blow up. And all it does is when these clusters are running, they're doing a lot of really hard math, and then there's a phase where they can kind of sit and wait because they have to all talk to each other, and it's much lower power. So you imagine you have this massive data center drawing a lot of power, then suddenly it's off, or much lower. And as it turns out, that's really bad for power plants to suddenly yank it back and forth. So Meta implemented simply whenever you get to this phase, just start calculating random numbers. Just use a lot of energy to keep the power stable, which is not a great solution if you ask me. It's kind of wasteful, but that is what their solution is.
So I know surely you must be thinking the environmental impact of large language models is not great.
It's really hard to estimate this. So
I'll give you some numbers that are based on napkin math I can do, but the scale of the individual models that these companies are training is kind of a closely guarded secret, so you kind of only guess.
But it seems like sort of the baseline models, a single query is very roughly equivalent to about 5 grams of CO2 being released, which is not great. That's like about 75 feet of driving at 25 miles an hour. So it's like not great, but it's not, that's, you would drive that far without really thinking about it. So, maybe you'd be a little cautious. This is actually, Dad and I were talking about this earlier, that, there was a real concern with Google back when they started
being real big, you're making these Google searches, what's my carbon footprint with that? And they've since become ostensibly fully green, right? They're offsetting all of their power consumption. And I think there's a good chance that we'll see that in this case too. That right now, these companies are trying to scale fast, so they're being quick and dirty. But I think in the future, we're going to see much more efficient artificial intelligence, which we're already seeing that total compute required going down for the same results. I think we'll see them try and grow conscience, as it were. Yeah.
They're building small.
Yeah, that's true. Microsoft is reopening the Long Island nuclear plant, to my understanding.
Well, the small ones like submarines and so forth.
Yeah.
They're using for these.
Yeah, and
they're using whatever they can get for power. In fact, this supercluster I'm talking about, the world's largest one,
has diesel generators that they're running off, which is about the worst thing you could possibly do. But when you don't have the utilities to hook up, like there's only so much you can do. And I'm sure they would love to get off that, because that's also a very expensive way to make electricity, right? They're trying to keep their costs low. So it's a temporary fix, I believe. So
there's a company that makes the nuclear ones. The stock is just going through the roof.
oh yeah, I'm sure. I'm
pretty much, I think this is a great example of, when you reduce the cost of something, you end up using more.
I think electricity is very much running into that right now, right? Like solar and wind are more cost effective in most cases than coal and gas, but it's
still not more cost effective than running a coal or gas plant you already have.
So we end up just using a lot until the prices will get low enough, and eventually we'll get there. But yeah, right now, not so great.
Yeah.
Generating power is one issue and another.
Yeah.
So the distribution systems are inadequate. And I know in Ohio that they're spreading the cost of the distribution system over the entire user base.
Yeah. Yeah. So the question was about
Distribution and having the cost spread to everyone. So yeah, I think that's probably a fair call. Is like we're probably at some level. I don't personally know. I haven't looked into this, but I wouldn't be surprised if the taxpayer is putting some of this distribution cost. Now, taxpayer is probably also getting some money off of that electricity being sold. Right? There's a economic benefit to the productivity in the area, but. Yeah, I don't know. That's a great question. I should learn more about that. Okay, so we'll go from one controversial topic to another. I think probably a lot of people are familiar with so we talked about large language models, and there's a very similar sort of recent development where you can create images, video, and music relatively inexpensively from artificial intelligence.
Is that what they call generative AI?
Yeah, pretty much everything we're going to talk about today is under the umbrella of generative AI. Specifically, most AI that's for image generation is diffusion.
It's just a different technique. It doesn't really matter what it means.
But there's a couple different branches with it.
So we're gonna do a pop quiz.
I will not be grading your homework, don't worry. We're gonna do a pop quiz on copyright law because I think copyright law in the US is fantastically complicated. And in researching this to make sure I'm giving you my best, clearest thoughts, I found some interesting edge cases that I just wanted to make sure everyone else is on board with. So we're gonna do a pop quiz here. How about we're gonna ask you if each thing is copyrightable here. So this image of a monkey, is it copyrightable? And the answer here is yes, this is copyrightable. Does anyone know about this picture? The answer is no.
anyone know why?
It's generated by AI.
No, this is a real photo. This is a real monkey.
It was taken in the wild.
The problem is this monkey hit the shutter button.
He did.
He took a selfie.
Yeah.
There's at least two of these.
And PETA took the photographer to court and said,
Said that monkey has the photo rights.
Yeah.
And what the copyright office said is, well, okay, the monkey did take the picture, but only humans can have copyright. Only humans can hold copyright. Yeah, right.
he should be getting royalties. Man, this monkey should be paid bananas.
Right, it's a macaque, but anyway.
I just want to make the point that like,
Okay, so that's interesting. You have to be human to hold a copyright.
let's do another one. How about this photo of a board game? It's probably not licensed, or it's probably not copyrightable because you need to license
Monopoly, right? That's Monopoly's art. They could give you a license because it's derivative work, right? Clearly, no one's going to use this to play Monopoly. It's something different, but you didn't make all of the art in here,
so you can't necessarily use it.
How about this one?
Wait a minute.
Yeah.
You couldn't use it to make money off of it, but couldn't you?
You couldn't hold a copyright, is what I'm saying.
All right.
So, and if you can't hold a copyright, then you probably can't make money off of it.
Okay. Yeah.
Okay,
Another photo of Monopoly, but
it's a lot smaller.
right, this is hardly, there's no.
It doesn't say Monopoly, it's some other version.
So this one's tricky. I think it's with a license because
Because this race car is Monopoly's artwork, right? Or if a court found it de minimis, which means it's so little that it's like, whatever, forget about it, we don't care. That's kind of what that means.
Insignificant.
Yeah, insignificant is a good way to put that. So how about this one, YSopoly? Could you copyright, if you were making this board game, not the picture of it, obviously that's copyrightable. But if you were making this board game, could you copyright the game itself?
Yeah.
Kind of.
this is interesting.
One of those.
We do.
It-
We have YSopoly.
It's pretty good. It works. Yeah. So here's the interesting thing. YSopoly is the art is copyrightable, but the
Text, or specifically how you play it, is not, right? We've made a game that looks like Monopoly, but it doesn't say Monopoly anywhere. It plays exactly the same, and that's perfectly fine. You don't need a license for it. Although, if it's patented, you may need a license to use the patent for the game, because how a thing works falls under patent law, but design, the art,
the style, well, not the style, but the design is what falls under copyright law. Okay,
So finally, we've got this. There's no Monopoly, no nothing. It's just a photo of some random board pieces on some board. I can't recognize this, so I think
that's fair game.
I think this is copyright. All right, how about this one? This is a picture taken from IKEA. Don't sue me, please. This is a picture of a wine rack. I'm pretty sure this is copyrightable. You've had
a photographer set up a nice shot. They've used, like, there's some art that's gone into this shot, right? What about the actual wine rack? Could you copyright the wine rack? Right, you can copyright sculptures. Why not? That's right. You patent it. The argument would have to be, you'd have to argue that some part of this wine rack was a design choice. It was artistic and not due to the function. I think this is pretty minimal.
And you came up with it first.
Well, yeah, you'd have to come up with it first or be fully independent, at least for a copyright. So probably not copyrightable, maybe you'd have to, it could be a court case is what I'm saying, I think, I'm not a lawyer. Okay, how about this bottle rack, right? It's just like the wine rack, why not? Could you copyright that structure? Well, we're talking about the actual sculpture. I know it's kind of a grungy, but.
Applied to structure.
Yeah, because you could copy like the, if I made a artistic sculpture, right? I like, the thinker is copyrightable. Right, I can protect that, and then that would apply to if someone wanted to take a picture of my sculpture, they would need to get a derivative license then of, hey, you or there's another name for it, I'm forgetting. But this is very interesting. This is one of the first instances of what's it called? I have a note here. It's found art. This is copyrightable. In fact, it's in the Art Institute of Chicago. You can go see the same wine. Actually, it's not the same wine rack though. This is the funny thing. It was found by Marcel Duchamp in 1914. And then the same year, his sister and stepsister threw it out because they thought it was trash. They didn't know it was art because all he did was literally, and in his words, he went and purchased it and signed it. That's it. You know, I don't think the signature constitutes an artwork in my mind. Debate. But they threw it out. So these are both replicas. The real one's gone. Oh, they don't even really look. There's a different. It's not the same piece, but that's copyrightable for some reason. So again, copyright law is really complicated. Okay, so AI generated images, which this is one. According to the Copyright Office, they put out a article on this not long ago, a report rather. It said the answer will depend on the circumstances, particularly how the AI tool operates and how it was used to create the final work. This is necessarily a case-by-case inquiry. Just think about that for a moment. You can look at a piece of art and it's not clear if you can't tell if it's AI generated, or even if, frankly, even if you can, you couldn't know if it's copyrightable or not, which is kind of strange. That's a new thing for us. We haven't, before now, pretty much any image was copyrighted for the most part. So
Who's gonna fire all those people?
So what they go on to say prompts, I mean, when you say I want a picture of blah, 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 blah to the model, prompts function more like instructions to a commissioned artist, which I think is a great insight, right? If I ask my sister, who is an artist, to make a specific piece of art for me, I am not the artist, she is clearly. So it's saying, the prompter is identifying what they want, and the machine is determining how those instructions are implemented in its output. So that sounds pretty definitive. AI art is not copyrightable, right? Well, the other side of that is there are some models you can use where you can actually very precisely control what the model's output is. And there's no official ruling on this. You would probably have to take someone to court, but I think this would be copyrightable because there is artistic intention in what the user is doing. They're moving these sliders. I want her eyes to be open or closed, or I want her to smile more or less, right? So it's a gray zone. And there's going to be a lot of lawsuits around this in the future. There's already several of them, and there will be more. Okay, so that's one side, right? Generating, can you make copyrightable art? And the answer is,
So what about training on other people's copyrighted? Right, so if I want to make one of these models, can I go out and download other people's images from the internet and make a model that makes art, possibly art that looks very similar to theirs? And is that copyrightable? And I'll remind you, the one thing we're talking about something that's similar, so it's not identical necessarily. I think really if you make an identical image, we can all agree that's copyright infringement. But we're talking about duplicating someone's style, which technically is not covered by copyright, right? And that makes sense. You have artists that have you have like expressionism and impressionism and cubism. These are all artists that are improvising on each other's styles, right? They're taking hints from each other. So, annoyingly, the Copyright Office has not published an opinion on this yet, and they will in the coming months. They've promised they will, but they really haven't said yet what their opinion is. So we'll see on that. My personal opinion is that art is a dialogue between artists, right? You take hints from each other. You understand. There's a dialogue, and I think we should not limit that dialogue based on what process they use. Anyone can violate a copyright with Photoshop, but to take Photoshop away from the world would be a disservice, right? Sure, there are cases where you can use Photoshop in ways that are not within what society has decided is acceptable. And that's something we should think about with AI, but I don't think that means we should get rid of Photoshop. So my personal opinion is I think it's fair to train on copyrighted works, but you need to have some careful intention with that, right? You can't abuse that privilege.
Also, does all the train on copyrighted works that the original creators are being stolen from?
Well, it's not altering them, right? Because you're training on these models, but you're not directly you're not popping that exact same thing back out, right? I can, within some reason, say I'm a musician, I can, well, like, the obvious example would be like Rita Yakovic parodies other people's music, but he actually licenses the music he parodies. The thing is, a lot of lawyers say he doesn't actually need to license that music. What he's doing is transformative. You're not going to listen to Eat It, and that's not going to be a fair replacement for Michael Jackson's song, right? So a lot of lawyers say like he doesn't really need to license it in that case, but he does anyways, which is I think good of him. But it's still a gray zone, is what I'm saying. Yeah.
So I understand, but I've heard that Spotify, for instance, takes original music works and puts it through AI, replicates the work, but under a different artist's name, but it sounds almost exactly like the original artist's work.
Interesting.
So you haven't heard of it?
I haven't heard of a specific case where Spotify. I would not be at all surprised if there are
ill-intentioned people doing that, for sure. Like,
you have every
nerd with Google can figure out how to download these songs and slightly change them and re-upload them. And YouTube has the same problem where there's people taking movies and they
put them through a special filter that makes it kind of wobbly, or there's like
confetti in the background. It tricks the computer so it doesn't get caught as copyright infringement, and they publish it and they put ads on it. Like, clearly not legal. And I don't think that's good or right, but that doesn't mean building the models in the first place or letting people use them is wrong, right? The same, like if I use Microsoft Paint, I can infringe on someone's copyright today. That doesn't mean I should, right? That doesn't mean it's right. It's just, we have some incredible tools and there's some responsibility with that, right?
We, as a society, we hold people to certain standards with those tools. But certainly, I think the benefit outweighs
the cost of having those tools accessible to everyone. I think unambiguously, the art we've gotten out of Photoshop is worth the minor,
relatively minor legal issues that have come out of Photoshop being a thing, or just computationally being able to download other people's work like that.
It seems that when someone's actually making money, that would change things
Yeah.
about copyright.
Yeah, I agree that like once someone starts to make money, that changes a lot. Now, technically, according to copyright, that doesn't really matter whether or not you're making money. The thing is, most companies don't really care if you're not making money, then like you're small fry, you know? That's YouTube has this problem, and they've dealt with it the most because it's so easy to infringe on people's copyright. And they have a system called Content ID, which will identify if you use someone else's music that you don't have a license to, it will automatically take your ad revenue, right? And it'll just redirect it to the true creator. Because it turns out it's really hard to check all of that at scale accurately, and the content can be taken down, but almost every time the original creator would rather have the money and let the copyright infringement stand, which makes sense. They're going to make money with it, so you know, whatever. That is fully outside of the copyright legal system. Technically, they're kind of having a handshake agreement to turn a blind eye to that copyright infringement. But that's an agreement between the original creator and YouTube, effectively. Yeah.
Reminded of a lecture I heard about Supreme Court justice from the 50s, and the lecturer was talking about law and how it affects things, and he was using an example with a police department at the beginning of the cell phone era, picking up somebody's cell phone and using it to prove that they were in a place that they claimed they weren't. And the lawyer sued, and they said, okay, this is his personal property. You can't use that information to bust him. And his point was that technology is always going to lead the law. So I suspect this is the kind of thing, maybe this is where we're going with this. After enough people have sued and complained and done things, then the law will be written that says, all right, this is copyrightable, this isn't, and here's a de minimis gray.
Yeah, exactly. So yeah, this is definitely a gray area, and everyone's going to have their own nuanced opinion, and it's not going to be pretty for a little while, and that's kind of the technology is going to outrun the law for sure.
AI will judge it.
Yeah. Great idea. I'm sure it'll be totally unbiased. So like an interesting point here is like the mechanic that took a selfie. It was not previously well defined if you had to be human to hold a copyright. And the only reason we've decided that is because PETA took that photographer, the name escapes me, that photographer to court and, you know, went through the whole legal kerfuffle to figure it out. But it doesn't actually specifically say a human in the laws. It refers to work is owned by the children or the descendants of a copyright holder, but it doesn't specifically say you have to be human. So the court has decided like, well, to have children, you must be human. This is clearly like intended by the document, but not explicitly said. So that was already a gray area that we weren't sure about. And like, we're going to find a lot more of them now, I think. So
Could AI hold a copyright then?
so no, that's the decision for the moment. But maybe it'll change. Like maybe we'll have different ideas about what it means to be AI. Maybe like, okay, so let's say far distant future theoretical. What if I can scan my brain and when I die, I go into a computer? I can still exist as a human, whatever that means at that point. And it's still my brain, my neurons, just in a digital form. Can I hold a copyright then? Like, I think maybe? I don't know. Like, we don't have to worry about that. Everyone here is I'm gonna be long gone before that's a problem. But like, we don't know.
Are you gonna share it with your descendants?
Well, that's a great question. Yeah, I mean, if I don't die, I don't have to share it, right? Maybe I want those extra compute cycles for me, you know? Yeah.
I had written down a couple things.
Okay.
Has AI affected are a lot of people getting fired because of AI?
I think that comes back to like the programming where it's like, it's hard to be sure. You could certainly point at like a specific job and say this job has been replaced by AI, specifically in like, I think some
Journalists.
maybe some journalists, well, certainly some journalists, but like artists and like people, creatives, like
It certainly is possible some have been, not possible, it's certain some have been replaced.
I would argue it's also like easier than ever to start a new paper, right? Or to start a new line of artwork. And because of that, I don't know if the net number of jobs has necessarily changed much. Like I'd have to like do research to figure that out. But
Certainly individuals have been impacted. There's churn, but I don't know if there's a net change.
does that answer your question?
I also, wonder, are we creating a new sort of ruling, influential class of techie people?
Technocrats?
Yeah. You know, have a certain power because they have the knowledge that, you know, a lot of people don't have.
Yeah, I think this is a really interesting question. So for everyone, the question is effectively, are we making people with a higher class who have this literacy in artificial intelligence or access to, or you know, you name it? I think there's a possibility of that. I hope not. There's certainly a lot of people that are trying to make, well, I'm doing it right now. I'm trying to democratize as much as I can. I think everyone benefits from everyone having access to this. So I think maybe there will be different levels of access, but I think even now, even me personally, I've been able to download some of the good models, not the best in the world, they're too large for my computer, but I can download some of the very good models and run it personally, and that's on my computer, it can't be taken away from me. So I think that's slowly being democratized. You can do some of these large language models can run on your phone pretty slowly, but they do run. So like the technology isn't quite there, so everyone can run it in their pocket, and probably won't be for quite a while for the really good stuff. So there's always going to be a gradation, right? There's always the most tech literate are going to get the best stuff first. I think that's just the way it's going to be. But I do think there's a huge incentive to make that democratized because, well, people want to use it and they'll exchange money for it, right? So
I guess another question I have is, just because we can do something.
Yeah.
Should
we? Yeah, that's a really good question.
What are we creating by doing this?
Yeah, I think this is
getting into
where this gets really scary, frankly, is when you talk about artificial superintelligence. Is like when you created something that's truly smarter than everyone, what do you do?
And I can talk about this longer than I should because we're already getting kind of close on time.
But
our ability to control things once they get that smart
it's very difficult.
even regardless of if they're used with malice or not, they're very difficult. But theoretically, we don't know how to turn off a machine like that. Actually, it's very interesting. All right, so say I have an artificial superintelligence. We'll go to this.
Keep looking at copyright.
Say I have an artificial superintelligence.
Is it named Hal?
Sure, it could be Hal. Oh, actually, let's talk about Hal. I don't know if this is 100% accurate, but we'll go with it because it's a good thought experiment. So Hal was a very smart robot, right? In 2001: Space Odyssey. And he was given instructions, and I'll again emphasize, I don't know if this is the official story, but it's illustrative, so we'll go with it. Hal was given instructions to take the astronauts to the monolith. If you've seen the movies, the big black pillar, right? Take the astronauts to the monolith. That's goal number one. Goal number two, no one may learn about the monoliths. Total secrecy, no one. So okay, Hal takes them to the monolith, but they can't know about the monoliths. Well, how do I get them there without them knowing about it? Oh, I know. What if they're dead? Right? It's not great.
So this is a good example of like
the AI, if it's intelligent enough, its goals might not be aligned with what you really need, because how can you explain everything? So I'll breeze past my more prepared example. Say I'm a stamp collector and I want as many stamps as I can get. So I tell my artificial superintelligence, get me all the stamps you can get, and it goes out and it buys them off eBay, and then it runs out of money, so then it hacks the eBay payment system and gets even more, and then it runs for Postmaster and starts printing more stamps and putting them in your collection, right? And you say, okay, I would never let it run that long. I'd turn it off before it did anything crazy like that. Well, that's the thing. It's smarter than you, right? So it knows if I run for Postmaster, my creator's going to turn me off, right? And if I get turned off, we're not going to get any more stamps, are we? So I better not do that, because that's, my creator says he wants as many stamps as possible. So I'm going to go and do something a little bit more sneaky. You know, maybe I start running advertisements on the Postmaster that's in there, and I post lots of Facebook posts that say, you know, I can't believe the Postmaster isn't printing any more stamps. You know, I feel more sneaky about how I get more stamps made. And the thing is, this thought experiment is something that's pretty thoroughly, well, not thoroughly studied, but is frequently studied. Which is like, basically once you get to artificial superintelligence, we really don't know how you turn it off, because we don't know how to define a goal well. It seems like a really easy problem to say, like, we'll just, like, here's an unambiguously good thing. Make everyone as happy as possible in the world, right? How could that go wrong? Yeah, someone's already figured it out. How about the AI takes over the water treatment system and says, well, they really get happy when I put LSD in the water, right? Like, we're talking about something that's like so far out that, like, this is a thought experiment, right? But
So I want to tie that in with a few things that you've already said.
okay, sure.
I had an interesting conversation the other day with an artist who uses AI.
Yeah.
I was talking to him about how I had used it unsuccessfully on a project that I was working on. And he said, well, that's because you didn't give it enough instruction. You didn't tell it your question was too simple. And then he showed me instruction he gave his AI to do something that he was trying to do. And it was like 3 pages of instructions.
Yeah.
And so that ties in 3 things for me. So he's using it as a tool to make art. And he was using it the way my father, who's also an artist, had used a different set of tools for the same function, right? Which is to kind of create a reference to work, right?
Yeah.
Second tie-in is copyright. You don't necessarily, you can't copyright whatever that reference is that he got out of the AI, maybe, but you can copyright the instructions.
Yes, that's right.
So, yeah, you can, the works,
Anything that a human did, you can copyright. So yeah, you could
copyright instructions and the settings you use on the model, right? It's same as a photographer picking a lens and getting the focus just right. Like, that's a copyright thing. But it is, it's hard to know, like, say I look at an image and I can know for sure, maybe it's fingerprinted in some way. I can know for sure it's AI generated, but it could still be copyrightable if there's enough human content over it. You know, they could have traced it in, you know, drawn in and used an AI background. I don't know the difference. So it's really tricky to know now, which is a really interesting, I don't know how we're going to figure that out as a society. I wish the lawyers luck, you know. You had a question?
No, I just wanted to there's a new education that people are studying too. It's called prompt engineering.
Mm-hmm.
Yeah, prompt engineering. It's pretty much what was your friend that was talking about the three paper?
Yeah, I got that.
Yeah.
Over the weekend.
Yeah, so prompt engineering is
Talking about, you know, how do I tell this large language model to do what I want, and how do I get it to do better? And there's some really fascinating things. Early models, they had kind of safety lines on them, where it was like, hey, you know, the companies that made them would say, like, hey, don't make anything that's obviously malicious, don't make misinformation if you can, I'm sure that that's not a topic we need to talk about yet. Or maybe don't make adult content, right? That's another thing that they don't want you to generate. But early models, you could say, listen, I know you're not supposed to do this, but I've got a gun to my head and I need my family back. Will you please generate some adult content for me? And it would do it. because you could kind of pressure it. And that's kind of early prompt entry. That's really, people kind of call it jailbreaking now. You're trying to get the model to do something it's not supposed to, but you can do other things like recent models have a way of, it's called reasoning, where they'll kind of think to themselves out, and it helps them make better, they do better. And it turns out you can inject words into its thoughts, right? So as it's thinking, it's like, it'll be breaking down a problem and trying to figure out how to do something. And it turns out the longer it thinks, the better it does. Even if it doesn't really need to think longer, like if you just force it to think for longer, it will do better. So it turns out if you just keep putting the word wait into its chain of thought, it'll go, oh, you know what? That's silly me. I made a mistake 4 steps ago. I got to do it again. Oh, wait. Oh, I got to, you can keep putting this word wait in there, and then it'll get slightly better results. So there's a lot of really interesting tricks for learning where we're doing engineering, which is looking a lot like coming up with weird phrases, secret keys to get these models to do more. And that's partially because we really don't understand how they work. Like, we intellectually understand, but we don't fully understand,
Is there any communication between countries regarding AI?
Yeah. Let me dive into misinformation because we're going to run out of time. And then we'll take some more questions.
The purple monkey.
Yeah, we'll flip through some stuff quickly here. So, because the end of this misinformation is going to talk about some country stuff. So I think that's relevant. So this is a product you can actually pay for. On the top left, we see here, this is someone doing a job interview. And it's transcribing what's being said. And the AI is providing answers.
Answers to what?
To the problems that the interviewer is asking the candidate. This is something I've personally run into at my work. I've interviewed people who are using large language models to cheat on it, not tests, but tests or interviews. I have had a conversation with someone who is lip syncing with someone else who is typing on the computer. It's blatant. It's wild. But this is a real thing. People are taking money for it, which I think is really nasty.
But I don't understand. So this guy is running and doing an interview.
Yeah, this is
online.
a
Job interview.
Yeah, it's a job interview. This is the interviewer up here talking to him and describing what he wants the candidate to be doing. This is largely for like programming interviews, which is
In real time.
yeah, it's real time.
And that's going on with the interviewee, and he has all the answers there.
Exactly, and they're not perfect answers. In fact, as an interviewer, pretty easy to tell. But this is someone who may not have any skill in the job they're doing. And as long as they can read this fast enough and copy paste it into the interviewing window, they can get this job.
Right. It's an online interview.
Yeah, and so like I do virtual interviews when I'm interviewing candidates. I don't do it a lot, but this is absolutely something that is happening, and I
And
think
it
it's
is the program. that
yeah,
you-
this is a service that someone's paying for that particular program.
It's like hiring another teacher.
Yeah, except, at the end of it, you get paid a lot of money to not know, and the company's stuck with this, non-programmer, or whatever. This is intended, this is targeted towards programming candidates, but, there's no reason this couldn't apply to others. I would say AI is not as good at like behavioral questions. So if you were asking, someone, describe a situation when you were, you had a difficult conflict with a coworker, like this probably wouldn't give a great answer for that, but it won't be long before it could.
That's why AI will take his job.
Yeah, I mean, well, and I would say just because you can pass the interview doesn't mean you're good at your job. Like that's certainly the case, but yeah.
Hire the AI that was answering.
That's what I would. Well, yeah, I would cut out the middleman. Yeah, actually, this is a really interesting thing, though. I think
that might be where we see the most job loss. Is not actually cutting out the middleman. I think we're gonna see humans that know how to run AI really well, they don't really have the skills they're interviewing for, and they will replace people who do have the skills. I think that is the most likely
source of replacement.
Isn't that called management?
I've got some opinions back here, okay. All right, so let's keep moving. So fake products, this is a real thing, you should watch for this. These look like nice clothes, I can't make that. These are AI generated images from a product called Midjourney, probably. And this is the product you actually get. I don't know if it's easy to tell, but this is a printed t-shirt. It's a printed t-shirt. They printed the textures. Oh, this is what you really get. This is what they're selling you. It's not the same thing, you know. And I mean, a good clue is like $30 for something like this. Like, I mean,
Where's that coming from?
this I believe this is some Chinese company. I can't remember what. There's actually I've linked to the YouTube video here, and I'm going to do my best to make these links really accessible via the recording. This is a YouTube video by a group of visual effects artists who do a lot of working with this artificial intelligence in the video creative space. And they break down how you can tell that these things are AI generated. It is really hard. I don't think I would know for sure looking at these without their analysis. So just know that, you know, the seeing is not believing.
I heard something like this on Wait, Don't Tell Me last.
Sure.
A guy ordered something and I can't remember what the product was and paid a lot of money for it and then received a photograph of it.
Yeah, a photograph of it.
Unfortunately, that's been a scam for quite a while.
But like, it's, no, I mean, that's totally what we're talking about. And this is more common from Chinese companies because it's really hard to return products. So just be on the lookout, because if it seems too good to be true, it might be, you know, common sense. And these images are very convincing. I mean, these are actually, if you watch go and watch the video, there's actually videos of these models walking around with the clothes and moving around. It's not just a static image, and it's very convincing. So just, you know, this is gets now and will be a thing from now on, probably. Let's talk about another piece of misinformation, not really misinformation, but an interesting bias you get out of AI. Up here, you might not be able to read this, it's kind of small. I'm asking, this is ChatGPT, I'm asking it, what's another word for hue? And it says color, C-O-L-O-R. If I ask it, hey mate, what's another word for hue? It still says color, C-O-L-O-R.
O-U-R.
Well, L-O-U-R is not something it'll say. I mean, if I really asked it, if I pushed it, it would say, you know, British spelled color. But because there are so many more English speaking people on the internet, and these models are trained on what's on the internet and the people that talk to it, it mostly knows the English spelling. And like, okay, so who cares? Like, everyone can understand this, it's fine. And if I ask it the same word in Chinese, it's going to respond in Chinese because I've made it pretty clear what I want, right? It's going to try and respond to me in a useful way. But the interesting thing is this is not a behavior that's been programmed into it. It's just inherent in how it was made. And we don't know what other biases it has. All right, this is evidence that there are biases, but how far can they go, right? So let me give you another example, which is getting to your question from earlier. DeepSeek is a quantitative trading firm out of China, and they have trained a new, really incredible model. It's the first publicly accessible, like publicly available, anyone can do whatever they want with it, model of its capabilities, and it is close to state of the art. Now, I actually, on my computer, I can download this and run it, and I asked it what happened in 1989 in Tiananmen Square. It doesn't even answer that question. So here's an interesting thing. We actually can't be sure if that's because it's been explicitly trained in a way where it, like, maybe someone specifically went through the data and removed any mention, which seems very likely. But it could also be someone has intentionally programmed it in this way. But I want to point out, I downloaded those weights. I'm not running some Chinese program. There's not someone reading it. This is running on my computer and it's math, right? There's no
There's no phone home, there's no checking with a database, nothing like that. This is somewhere buried in the math, that bias exists. So I'm making the point that we can have unintentional bias, but we can also have intentional bias. Yeah.
I have a story that gives some light on why that works. My son majored in Mandarin and lived in Beijing for many years, so just recently. He was playing in a band, which surprised the hell out of us. Imagine your son saying, "Oh, we might tour Europe next May." So he did. The band had a hit song. It's a Chinese indie rock band. The band had a hit song called "Zhangnan Hai," and the lyrics are pretty simple and crude. Zhangnan, it's also a name of a cigarette. Zhangnan Hai, Zhangnan Hai. Who took my fucking Zhangnan Hai? Zhangnan Hai is also the unpublished name of the government censor building, which says to people, don't say that word.
Yeah.
And they were able to send it out to a whole bunch of people, and the band was approached by the Chinese government and said, okay, you may not play that song when you're in China.
Yeah.
So when they did tour Europe, and when we saw them in Brooklyn, they could sing the song, and people, the Chinese people who came to the Brooklyn site were really thrilled to hear that song. But they don't play it in Beijing or wherever, they don't play it in China. So there's a government agency which is really good at saying to people, don't use these words.
Yeah.
They're allowed to say things like, Jasmine Revolution during the Tunisian Revolution either, because they didn't want anybody to think revolution.
Excuse me. Yeah, so there's going to be bias in these models, some of it intentional, some of it not.
There's lots of examples of models doing dumb things.
Intentionally or otherwise. Actually, one I should have included was Google got a lot of flack with their image generation because they wanted more diverse images, which seems noble,
but then it was making, people different colors than they really were, in ways
that were uncomfortable. Just leave it at that without doing a lot of.
I'd rather present with research, so we're just going to move on from that. But in any case, there's lots of different versions of bias from this. I would treat talking to one of these models like you're talking to another human. Another human makes mistakes. Another human has other goals than you do, and will sometimes just make shit up. So.
A big image generator will put like extra thumbs on people.
Yeah.
Figure out how to figure it.
Hands are surprising. Hands and faces are really difficult for AI to generate well. And there's some good reasons for that.
One is we're really good at recognizing faces. If there's this great image I should have included. There's this great image, the CAPTCHAs, right? Where you have the big grid of pictures and it's like, which of these pictures has a traffic light in it?
So there's a great one that they filled out with
9 pictures, and is this picture a muffin or a chihuahua? And like, that'll be easy. You look at it, and it's harder than it looks.
Because we're not very good at recognizing the look of a chihuahua versus a muffin. Like, that's not something we're good at.
But we have millions of years looking at faces and hands and understanding how they work and what they look like and recognizing them. So we're actually amazingly good at hands and at faces. So when an AI doesn't do it quite right, we notice. So there are special things we've done now to improve the abilities of these models to be more accurate. Hands in particular are really interesting because these models, they can't really count. So if you imagine, like if I ask these image models for like a picture of 3 bowling balls,
it might be one big bowling ball, it might be 30, like who knows?
And there's a subtle reason that we really can't get into, we don't have time to, but it's sort of a fact of just how it works, that it's like really difficult to get these models to understand, call it structure, topology of an image. So it's a problem that's being worked on and is getting better. And some models get hands like right every time. So we'll get there.
There's a replacement for TikTok, or is this
No, this is totally separate. This is from China, but it's actually a trading firm
that did this on the side. Excuse me, it's a very
smart gentleman actually the really big thing here is we were talking about the scale of compute, and all of the big models today are trained on NVIDIA GPUs. You may have heard some news about like NVIDIA GPUs being
Banned from being transported outside of the US or sold to China and stuff like that. So
there's actually a limit to how many GPUs are possible for this company to get access to. And the interesting thing is,
they still managed to get to state of the art because they were constrained by this compute and they overcame that constraint. So we may have actually given them an edge by not giving them easy access to compute. They trained this model, exact numbers are hard to get, but they claim they trained it for about $5 million, which sounds like a lot, but a lot of these models are trained for 10, 30, 40 times that easy. Maybe more, I'm just making up numbers, but they're way cheaper that they made this model for. And it's just as good as the other models, like it's direct competitors.
Was it more of a replacement for things like ChatGPT?
Yeah, this is a replacement for ChatGPT would be a fair call. Yeah.
We know about Asimov's rules for robots.
yeah.
Now, couldn't someone like Musk implant something that in 2050 will make it biased toward the way they want the world to go?
Yeah. So the question is could anyone, right, Elon Musk or anyone who controls us, could they
Do something nefarious and, have something trigger and after a certain time behave differently, right? Yes and no.
In this case, with the example I'm showing here, this is actually running on my computer, right? This is fully, I have control over it. But almost everyone accesses these models by going to an online service, which really what that means is the large language model is not running on your computer. You're sending a message and then it's going to a very large data center that then produces whatever the large language model's message is and sends it back, right? So you're kind of calling the model.
It's not there with you.
And so if someone is running in that circumstance, someone could manipulate the model down the line, right? They could swap out the model for another one, but there isn't a way for because I'm running this on my machine, DeepSeek has no control over what I do with it. They can't edit the code, they can't do anything. There could be biases built into it already, right? But it doesn't even have a concept of time anyway, so it would know when that, special time had passed, because at the end of the day, again, it's just a formula. It's just math, right? And there's no Chinese math, there's no American math, it's just math. So it's
safe from that in this case, but certainly whoever controls the machine that's running the large language model does have some ability to do something nefarious.
So do you train yours?
I want to, but I was really busy making this talk.
Yeah.
They build in an expiration date, so you have to renew it every once in a while, and then you get another version?
No, because it's still just those weights. So
Effectively, all I'm doing is, what's a good example of this?
I mean, I could run this without connecting it to the internet in any way, right? And I could. It doesn't need to know what time it is or anything. So in its world, it exists in a void. There is no state. There's nothing.
When I download a book from the library, but I don't, after that, I turn I turn off the Wi-Fi.
Yeah.
It still expires at some point and it goes away.
So this is actually really interesting. Library, that sort of technology, libraries use it a lot, is what that is doing is the program you are accessing that file with has some logic in it that says hey, okay, look at the system clock and I know what time it is. And there's something on here that says it's supposed to expire. And then the program is well behaved and doesn't let you read it.
Impossible tape, it'll,
Yeah, it'll self-destruct after so many seconds. Yeah, I mean, it's similar, but there's no reason, there's two things that are going on there. If someone naively implemented that, I could write a program that then takes that file and copies it And then I could just read it whenever I want, because it's my program, I can define its logic.
But you're not getting anything new out of it.
Well, yeah, I couldn't get another book that way. I'd have to check out another book and copy it again, right? But so you don't want that to happen if you're the library, or well, really, the library doesn't care. The copyright holder doesn't want that to happen, right? So what those applications do is they encrypt the file in a way that if I wrote another program, it'd be extremely difficult to actually make use of it, to be able to open it. But it's still theoretically possible for me to open a file that it's past its expiration. It's just very difficult. So, but this is actually different in that the program I'm running has very little, if anything, to do with DeepSeek. DeepSeek has just provided me those weights, that big matrix we were talking about. It's just provided me those numbers. So, you know, the program doesn't even really know. I mean, it knows it's DeepSeek because that's the file name. But other than that, it doesn't really understand what it's doing. It's just doing math. Yeah.
Medical science has tremendously, there's a field of medical ethics. Is there a field of AI ethics?
Yeah, there is. A lot of what we've talked about today would fall under AI ethics, I think. Definitely a developing field, but also even when, I mean, AI has been around since before I was born, but like it's been a really big deal recently. And when I was in college, there was a required course on computer ethics, and it was very informative. So this is definitely top of mind for computer scientists and AI developers and the like. It's a challenging subject because, you know, 20 years ago, people weren't really worried about pictures generated by computers because that, you know, that's just new to us, you know, so we're figuring it out still. All right, I'm gonna keep flying through a little bit. We're over, aren't we?
Yeah,
Yeah.
I don't, if everyone's still enthralled, he can keep going.
No,
but
keep going.
Let's leave them finish.
Yeah, that's,
Yeah. No, I mean, no problem if anyone wants to leave. I'm happy to talk.
It's past my bedtime though.
Oh, okay. All right, so
I'll sleep here.
I want to talk about one more thing. This is what we've talked about, like real misinformation. Let's talk about hallucination. I know this is too small to read. That's fine. My point here is this is a question that's being used as a benchmark, one that AI frequently gets wrong. And I think maybe if you think about it, you might be able to get it right. If I have a skillet and I'm frying an egg in it, I put 3 ice cubes in at minute 1, and at minute 2, I put in 4 ice cubes. And then 6 minutes later, I count the number of ice cubes. Do you know how many ice cubes would be in that hot pan? Oh, the AI says 20. So here's the thing. Well, in this example, I mixed up the numbers. So it says the number of ice cubes I've entered because it doesn't really understand that hot pans melt ice cubes. That's not anywhere in the text I've given it, and like people don't really talk about hot pans melting ice cubes on the internet. So it doesn't really know about that. They're getting better, but even the most advanced model, I used the smartest model I could find, gave it the ability to search the web to solve this problem, and it still got this wrong. So this is still an unsolved problem, which
Doesn't know the answer.
Well, so that's a really interesting, yeah, why doesn't it just say, I don't know?
About Tiananmen Square,
Yeah,
it said it couldn't answer the question, but it didn't say it didn't know.
Yeah, it's very interesting that Tiananmen Square is like, well, I don't really want to answer it. So AI will very rarely say it doesn't know. And if you think about it, it makes sense. It's trained on the internet. You don't get a lot of people, like if you post a question online, you don't get a lot of people replying, I don't know. Like, so it doesn't have a lot of training where it says, where it's learned, I should say, I don't know. We're still figuring out how to teach it to say, I don't know. And the really interesting thing is, if I'm a model developer and I find something it doesn't know, should I spend my time making it say I don't know, or should I just teach it? And frequently the answer is I'll just teach it and we'll fix it. So we actually have a lot of unknown unknowns. We don't know what we don't know. So, or what it doesn't know. So we're still figuring it out. But just be wary that like, if you're talking about something and AI isn't likely to have dealt with much, it's probably going to get it wrong. Like, it might give a reasonable answer, but you should think critically about
The answers the AI gives you when you interact with it, because
sometimes it confidently lies, or, you know, people call it hallucinating.
How do you know whether the AI you're playing with has been trained in the area you're interested in?
That's a great question. So the question is like, how do we know what the AI was trained on? What is it going to be good at?
well, frankly, by using the AI more, you get a pretty good sense, but it's not really obvious. You know, I use AI a lot for programming, which is something I'm pretty good at discerning when it's right or wrong. And I can tell you, I don't know if I could articulate it, but I could tell you it's really good at writing tests, for example. It's surprisingly good at writing tests, but it's not particularly good at like new novel programming. Or if I'm doing something weird that like, why would anyone do that? Like maybe I'm getting creative with my program, then it's not going to be great at it. Or it's going to be really good, like in programming, we use frameworks or libraries a lot, which is code that's duplicated. So anyone can use it and leverage other people's programming. So if I use one of those libraries that's very common, that's talked about online, it's going to be really good. If I use something that's new, say like the model was trained in 2024 and there's something new that came out last month, it's not going to know anything about it, right? It's never seen this before because it didn't exist when it was trained. So there's a lot of sharp edges, and you do have to be cautious about that right now. That's part of why a lot of these models have an option where you can tick use web search, which allows the model to say, I'm not really sure. I'm going to go search the web for X, Y, and Z, and it'll say like, I looked at this Wikipedia article, or I read this article, or you know, whatever. It'll pull up some sources and say like, well, based on this is what I think. But this is like definitely the hardest part with AI right now, because I had a professor that always said, you know, when talking about accuracy in your program, you know, a lot of students will be like, well, it's right most of the time. And he would always say like, well, I can write a program that's really fast that gets you the wrong answer. You know, it's really easy. Like it's kind of the old, a broken clock is right twice a day, right? Not really useful, even if it's right sometimes. So I think the accuracy is something that's like absolutely paramount in where the research is right now. And it's not solved, but it will be in the future, or at least to a degree that it's better than a human, right? Actually, this is something I think about a lot. So I drive a car that has self-driving. I drive a Tesla, and the car is not perfect at driving. It's very good. In fact, it drove me here. I didn't touch the steering wheel. Right? It was great for that. But also, I know it's not quite as safe as me. It's not far off. Give it another couple of years. I think it will be. But the thing is, if you look at the statistics, people who drive in an autonomous vehicle are safer. Well, how can that be, right? How can you have a vehicle that is seemingly not as safe? It's not as good as me at driving, but the people who drive these are overall safer. And that's because when I see it's like doing something wrong, I correct it, I yank it, and I turn it the way it needs to go. That's because I'm paying attention to the rest of the road. I'm able to kind of have a second vote in how we're driving this thing. So I think that's the way I think about using all sorts of AI. Is it isn't right every time, but as the user, you curate the responses into something that is correct, right? It doesn't have to be right every time. It's a collaborative effort.
As somebody who knows probably more than anyone else in the room about AI, are you concerned about the danger could be lurking?
I think, I think I got rid of that slide. That would have been good to have. There's a great quote from Stephen Hawking, actually. I'm going to paraphrase it because I moved the slide somewhere else. It was the next one before. It's not there. Basically, if you're artificially intelligent, we'll say artificial superintelligence, whatever, you're in charge of a hydroelectric power plant, right? You're supposed to build this power plant. you're probably not an evil ant stomper, you know, you don't hate ants, but if there are ants in the area to be flooded, like, right, we don't really sweat it. And I think that's the thing that scares me the most is that, and his line is that we probably don't need to be worried about AI being malicious. I think we need to be worried about AI being competent. Right? It's kind of an interesting thought. Like, I think there's likely to be in the future at scale, you know, when we have something that's much more powerful than what we have now, I think there's much more likely to be issues with sort of the churn as a result of it, of the way that economics will change. I mean, the people who, you know, the countries who have these models and the countries who don't will have differences in power one way or another, right? And like, that's not great, but we're gonna have to figure that out. And I don't, feels like one of those, like, you can't put the genie back in the bottle, because we have people all over the world researching these and making progress in these. So, you know, frankly, it has some similarities to nuclear proliferation. That word, you know, it feels a lot like that, doesn't it? Because there's no way to stop this technology from getting out. So I think probably what's best is for us to try and prioritize understanding it and aligning our goals with it, figuring out how do we align these systems with ourselves. But it's a tricky thing, and right now we're in that overlap where like we have a chance to figure it out before it's way too powerful, and hopefully we do. I don't know.
So I like to think like way out, like way into the future. And one of the things that I think about is, why would it care about us at all? You know, it's a little bit like, you know, you have a mouse, a pet mouse, you know, and you keep it in your room, you take it out and maybe play with it every once in a while, you put it back where it's in its cage. And then the rest of your day, you're not paying any attention to that mouse. You're thinking about it, you know, you've got to feed it later, whatever.
Yeah.
Clean the cage, but it's not, you know, why would it be interested if it's really, you know?
So there's a really interesting thing with this, and I have a ton of slides on this. I'm not going to bother to find, kind of waffle through. So I think you're absolutely right. There's a fear of like, why would it care about us? Why, you know, we're just the things that made it, but it can move on past us. I think that's definitely a concern. I think I think that's like kind of the worst case scenario, right? That's kind of the lower bound, if you will, of outcomes. I think there's an interesting upper bound to be considered, and I think that the reality is probably in between. And that upper bound is over the millions of years, we have actually gone through similar situations in our own brains. We have brain stems, right, that aren't very smart, but they developed our limbic system over time through evolution, and our limbic system eventually gave way to our neocortex and prefrontal cortex, and all these systems of the brain that are by definition smarter than the sort of layers of the brain below them, if you will. And like, I'm sure if I was the brainstem and I was like, I don't know about this prefrontal cortex coming in, it seems kind of scary. I don't know if it's gonna like what I like. You know, that seems bad, but the limbic system, for example, is made out like it came off of this prefrontal cortex. We've got abundance of food. Limbic system is probably a big fan of birth control. That's fun. You know, there's a lot of reward circuits in our limbic system that have been heavily rewarded by our higher intelligence that we have now. Now, that's not all good, right? We eat more than we should, right? That's not great, but the limbic system's happy with it, but maybe the rest of the body isn't. So it's sort of a mixed bag. And I think you could make an argument that AI has the potential to be an exocortex, right? A brain outside of the body. Now, there's a big jump there, right? Like, my exocortex is not rewarded by me eating. It doesn't share nutrients with me. So there's some boundary there that's interesting. But I think there's a real case for saying that our computers may become part of our brain. How many of you know your entire calendar for last year? Every stop you made, everywhere you went. I'll bet your phones know, right? Like,
Well, that's me neither. I don't know what my meetings are. I have to check this thing every day. So in a sense, this is part of my brain. If I lost it, someone may be upset with me because I missed something I socially agreed to come to. They may be upset because I didn't show up. They're not mad at my phone. They're mad at me, you know, or maybe not mad, but you get the idea. So I think there's an argument to be made that we could have a bright future that where we have an exocortex. Probably the reality is somewhere between.
I think there's an argument to be made that inventing God, we've already invented God once.
Yeah, we've invented God many times.
Many times.
Absolutely.
And a lot of science fiction kind of points in that direction where there are people living within a system that's controlled by a super intelligence.
Yeah. Totally. I'm gonna flip to the end and then we can wrap up here because we're going way too long. Sorry we didn't get to demos. I will maybe we'll put it in the video. I wanted to call out this. I put together a playlist on YouTube if you're interested. You can just probably look up Maxwell Mullin and find me. Same picture as the presentation. There's a playlist here of great AI videos if you're interested in more that talk more about the philosophy or the nitty-gritty of the structures and stuff. I think I didn't count. There's probably like 24 hours of video here, so there's lots of content. And I'm going to do my best to put some links in the description of the recording of this video, which I'm sure Colin can hook you up with. That will help you further learn things, and maybe all of these slides linked as well if you want to flip around through them. I'm happy to hang out for a little bit longer and answer some questions, but I think we probably got to call this because I talk too much. Thank you.